Hello and welcome to the Side1 YouTube channel. My name is Ray, and in this video we're going to continue on with the installation of the second Raspberry Pi with touchscreen. I'm also going to play a little bit with the power systems on Fred. One of the things I want to do is set up the system so it will work from the 20-volt batteries that I've been able to mount on his back. To that end, I've got the back cover off, and I've modified this switch. This is a 240 volt or 250 volt AC switch. It had a neon light in it, so I pulled it apart, pulled the neon light out and put an LED in instead, and then marked positive and negative on the switch so that I know which way to wire it up. The LED is connected to the middle pins, so if I supply power to the top pins, when you flip the switch one way, it supplies power then to the common terminals, the middle ones, and the LED comes on and power is available for the rest of the robot. Now that'll be great for controlling the servos. This has got a 15 amp rating on it, which is more than enough for what we need for the servos at 20 volts. I don't want to switch the Raspberry Pis through this. I would like to be able to isolate the servos. You know, when things go wrong, you turn the power off to the servos and stop it from moving. But I don't want the Raspberry Pis losing power unexpectedly. So to that end, I've managed to find and recover this. This is a small key operated switch, folds in with a nut. Key is removable in both positions, so I can keep the Raspberry Pis on with the key out. There's no chance of accidentally powering them down, and this would get its power before the servos, so from the top side of that switch. On the other side I have another switch, and I'm thinking that I have two batteries and I might wire the top side for one battery, the bottom side for the other battery, and then run the common to feed the top side of this one. I will need to put some sort of a capacitor on to cope with the switchover period to keep power to the various power supplies. Just for that moment. It doesn't have to be overly large, it's only a moment that it switches over for. So to mount this, I was thinking possibly just above this switch. So to do that, I'll need to drill a hole and open it up. Now to work out what size hole I needed, I've got this drill guide, and it turns out when you poke this through, a 10mm hole will cover the body. Now this has got some flats on it, and to get past the threads you need to take it out to about 11.5mm. But if I drill it to 10 and then file out up and down, that will leave flats, and that'll stop this from being able to turn in the hole. So I think that's what I will do. Unfortunately, the biggest drill I have on hand is only 8mm, but I do have this reamer which will allow me to take it out to 10mm and get a nice tight fit. So once I've got that mounted, I also want an easy way to be able to disconnect the wires off. So I have got, this is soldered, and that's not my preferred method, but I haven't got much of a choice. So what I'm thinking is, if I use this screw terminal, I can mount that to, say, this point here, or in around here somewhere, doesn't really matter. And then the wires can come from here into here, and the other one through the switch and into here, and then I can run the two sets of wires for the currently two Raspberry Pi setups from the top of that and out. Now in previous videos, when I wired up Fred's head, I used some fairly heavy wire for the Raspberry Pi power supply, and then I used the lighter building wire that I had, the 26 gauge AWG. for the servo in the head. Now this wire is closer to 1 or 1.5 millimeters. It's overkill. It's way overkill for this. This is more the size I need to run between these switches and to run to the other bigger servo drivers. So I'll take this off and I will attach the same color wires as I'm using for the power supply that's feeding the second Raspberry Pi, and that way we can keep the color coding similar. So that's the other thing I need to do, and then have enough length on those wires so that when I remove this cover I can actually get the screwdriver in to undo them. Although a plug would be better, I just don't have one at hand. So with all of that explanation in place, let's get started. Well, the plan was to have that as an elongated hole and then do the nut up. However, I can't turn the nut. There's not enough clearance around with this framework here in order to turn a nut. So that gives me two choices. I can either cut out around here somehow so that I can get the nut in to turn. I can get the nut to slot in there and then I can push the switch into it, but I can't rotate the switch obviously. The other option is to open the hole up further and then I can rotate the switch in and the nut will be held stationary by the framework. And I'm actually tempted to lean towards rotating the switch in, but being a rotary switch, it's probably better to have those flat. So I might have to get a power tool and Dremel out either side to allow the nut to turn. So that's my next course of action. Okay, so this heavier cable here is from the 60 volt 12 amp adjustable power supply that I have. I've actually set an upper limit of 30 volts because that's all the switch mode power supplies will handle, but that's feeding on one side. The battery feeds on the other, so I can switch between battery or power supply. This switch switches the power on and off for the servos. So the power supply is currently off, but I can switch it to run from battery. The key switch I haven't tested yet. It should have battery power on it at the moment. So I'll get a multimeter. Let's move that out of the way. Yeah, between there and there I should have 20 volts. And that tells me the switch is currently in the on position, which is green. That's the key. So that should be off. And we have 0 volts, so switching it on gives us 20 volts independent of the servo switch. What I can do is put in a capacitor at a later date, probably connecting up to here, just to bridge the switch over on this switch on this side. But yeah, that'll work for that now. Do I leave that switch on or off? I left it on. So we'll turn that off. And we'll disconnect this battery. Pull that, disconnect that for the time being. Okay, so these tails here go into a connector set I've got up here, which supply power to the 2 switch mode power supplies for servos that I currently have. It's a 5-way connector block, and there's room in there for 2 more sets because I'll have 2 more of the. Okay, so this is the connector blocks I was trying to talk about. These distribute power for the servos. The brown and blue wires going up to the head for the servo motors. These are the heavier wires for the heavier motors on servos. There will be 2 more of these going in, 1 in each arm. These are a 5-way, so I've used 2 terminals. I'll use up another tunnel in this, and then the 2 remaining for the other 2 switch mode power supplies. So that leaves running the wires down through the neck and connecting up to the small switch mode power supply, which connects to the Raspberry Pi. So I shall work on that now. I really need to build a robot arm to adjust that for me. So that might be one of the upcoming videos or series of building a robotic arm to adjust my camera. Hey, next trick, get the wires the right length. Okay, so this is a mount that I printed out for the AT30. I'll put a link in the description to where you can download it. The single screw hole there takes an M3 screw just to hold the power supply in there, and it has two recessed holes to screw it back. This was actually designed to go in the head, and that's where I've used it before. There's actually two of these in the head. I was thinking of mounting it over on this side. I think that doesn't work. Okay, so that's the wiring side complete. I haven't connected the second battery holder up yet. I've currently got the power supply connected to that point, and I will switch over to using the power supply because it's easier on the batteries that way. The servos currently don't have power because I haven't turned that switch on, so the switch on the left is the one that turns the servo power on and off. The key switch above it is for the two Raspberry Pis. The switch on the right will switch between the left and the right battery, but at the moment it's set for the right battery, which is down, and when up it will eventually select the left battery, but for now I've got it selecting the power supply, which is currently turned off. So in the next video I'm going to configure the networking. There's a couple of ways I can do the networking, and the major reason I'm using the wire link in there is so that I can have routing set up. The robot is not dependent on the Wi-Fi at home, and I can actually set it up with two Wi-Fis. One Wi-Fi to link to home. The second Wi-Fi will be sort of like a hotspot that I can connect my phone and or tablet to gain access to all the Raspberry Pis via routing. So when I set that up, I'll go through, I'll explain how networking and routing works, the various OSI layers, and how that affects the way the network will work, and how we'll set up custom routing rules. So I will have to have custom routing rules in both the Raspberry Pis in this case. I will also need to set one up in my router. I will only explain that one rather than show because it changes with router to router. So we'll call that quits on this video today. If you like these videos, don't forget to click on like to be notified when the next video comes out. Click on subscribe and ring that notification bell. There is a Discord server, the link is in the description, where you can ask questions and we can answer through there. I also have a Patreon account set up, and there will also be a link in the description for that. So we'll see you in the next video.